Now in this PowerPoint, we're going to be looking at interpreting expressions, which are mathematical expressions and equations. So when we look at these right here, mathematical expressions or equations can be used to model relationships and situations in the real world. These models can be used to understand the relationship between quantities and make predictions about them. Now we're looking at vocabulary. Vocabulary is extremely important. You have to understand what each part of these equations mean, or these expressions. So when we look at a coefficient, we're talking about a number multiplied by a variable. It represents the rate. Then you have a constant term, which is a number that does not change. It's a fixed term. Then you have a variable, which is any letter that stands for an unknown number. The most common letter that we use is the X. The dependent variable is your output, which is your Y. Your independent variable is your input, which is your X. And then you have a term, which is a combination of constants and of variables joined by multiplication or division. I have two real-world scenarios right here. So when I look at this example A, if Ian was born in 1998, you can change his age by subtracting 1998 from the current year. So we've already written Y equals X minus 1998, and if you don't see a coefficient, a number in front of the variable right here, X, then it's understood to be a 1. So the Y is your dependent variable, your 1 is the coefficient, and your dependent variable is the X, and then the constant term right here is 1998. So this just explains everything in words that I just said. Now example B, Takasha is driving to his grandmother's house, which is 125 miles away. He is driving at a constant speed of 55 miles per hour. So Takasha's distance from his grandmother's house, H hours after leaving, can be described by the equation D equals 125 minus 55H. Now your dependent variable is your D right here. And this is the one that will change. Now your constant term is 125. Your coefficient right here is your 55. And your independent variable right here is your H. Now look at these expressions right here. You have 7x minus 9. So what is the variable? Number 2, 3x plus 12. What's the constant? Number 3, 90 plus 5z. What is the coefficient? And H, T equals 0.7n minus 1.3. What is the dependent variable? So put me on pause while you think about it. Now look at your answers right here. I've already written them down for you. What is the variable? In this expression is X. And then on this one, the constant term is 12. And on number 3, the coefficient of Z is 5. And the dependent variable is your T. That is the one that constantly changes. Now, look at these parts right here in this real-world scenario. You're going to answer 5 through 8 according to this scenario right here. You have a plumber who charges a flat fee for each job plus an hourly rate for the number of hours the job takes to complete. The total cost of the job in hours can be modeled by the equation Y equals 50 plus 65x. So number 5, what does the independent variable in the expression represent in this situation? Number 6, what does the coefficient in an expression represent in this situation? Number 7, what does the constant term in this expression represent in this situation? And number 8, what does the dependent variable in this expression represent in this situation? Now, I want you to put me on pause while you think about it and see if you can come up with the answers. So, if we look at these answers now, you see right here, I have taken this Y equals to 50 plus 65x and I have rewritten it as Y equals 65x plus 50. Either way is certainly fine. And so look at number 5. So when we're looking at number 5, the independent variable is talking about C, the number of hours to complete the job, which is your X. Number 6, what does the coefficient in expression representing this situation is A, the cost per hour, which is $65. Number 7, what does the constant term in the expression represent in this situation? It's talking about D, which is the flat fee, $50. Number 8, what does the dependent variable in this represent in this expression, in this situation? And we're looking at B, which is the total cost of the job per hour, or total cost that you are going to pay the gentleman for coming to fix your whatever plumbing needs that you have. Now, I want you to look over here at this. Here's another way to write this. And so when I look at this right here, the Y is talking about the total cost of the job. The 65 is cost per hour. The X is the number of hours it takes to complete the job. And the 50 is the flat fee. Make sure that you're going to have to be able to look at each part of this equation right here and tell me what each part means. Now, look at this one. Look at number 9. You're given an explanation for each question. So you've got a colony of bacteria which doubles every hour. The expression 250 times 2 to the t power gives the number of bacteria after h hours, which that is h, not a t. So what does the 250 in the expression represent? So I want you to put me on pause while you think about it. Now, when we're looking at the 250 right here, 250 is the constant term. It tells how much bacteria is in the colony. Look at this real world scenario. Number 10, Brian is riding his bicycle at a constant speed from school to the library. His distance from the library in kilometers, x hours after leaving school can be modeled by the equation y equals 20 minus 12x. What do the x, y, 20, and 12 each represent in this equation? Be sure to specify the units. So now, when I look at this right here, you're going to fill in the letters x, y, and 20 and 12 to see which one each one of these represent. Put me on pause when you do this. Now, I've already gone through here and typed everything in. So the independent variable in this situation is your x. Your dependent, which is your y, is talking about the distance from the library. The 20 is the constant term, which is 20 kilometers, and 12 is the coefficient of for the kilometers per hour. Now, when we look at this right here, you see that y is talking about the total distance from the library. So 20 is the constant term, 12 is the kilometers per hour, and then you have your x, which is the number of hours he rides his bike. So make sure that you're able to do this part right here. You are going to have to be able to know this inside and out.